in the spirit of continuing on with things you already know, if there was one thing you're going to learn from this class, it is the relationship between cosine and sine and the circle. And we know that the x-coordinate on the unit circle is the cosine of the angle, and the y-coordinate is the sine of the angle. And if the radius equals 1, that is true, right? That has to be true only if the radius equals 1. That's a 1. Let's make it look like a 1. Maybe I'll just make it a simple sans serif 1. There we go. So it should be clear from the Pythagorean theorem that x squared plus y squared equals the hypotenuse squared. Well, if the hypotenuse is 1, then the hypotenuse squared is 1. But wait a second, if y is the same thing as the sine of theta, and if x is the same thing as the cosine of theta, then that leads us to believe that the sine squared of theta plus the cosine squared of theta equals 1 for any value of theta. I encourage you to play around with that. Pick a value of theta, say pi over 6. Figure out what the sine of pi over 6 is, and square it. Figure out what the cosine of pi over 6 is, and square it. Add them up. You better get 1. And that's going to be true no matter which theta value you pick. Literally any theta value at all. You could even pull out a calculator and play around with crazy values like pi over 11. And every single time you're going to find that the sine squared of that angle plus the cosine squared of that angle will equal 1. So this is everyone's favorite trigonometric identity. You don't get a choice. Everyone has to choose this one as their favorite. It is the most important. It shows up all the time, and it's going to be very useful. Now, there are a few different versions of it. The one that you see right here in the table is the most common one, but if we take that one and we divide everything by the cosine squared of theta, we're allowed to do that because it's an equation, right? We can divide the sine squared of theta by the cosine squared of theta, and also the cosine squared of theta by the cosine squared of theta, as long as we divide the 1 on the other side of the equation by the cosine squared of theta. And since we know our reciprocal and ratio, or quotient identities, we know that sine over cosine is tangent, so if we square both, we have tangent squared of theta. And cosine squared divided by cosine squared, well, I think we all know that that's equal to 1. And the reciprocal of cosine is secant, so we've got secant squared of theta. All right, so this is another Pythagorean identity. Tangent squared of theta plus 1 equals the secant squared of theta. And again, that's going to be true for all values of theta. And then if we wanted to try one more time, take that original sine squared plus cosine squared equals 1 and divide everything by sine squared, then we'll end up getting 1 plus the cotangent squared of theta is equal to the cosecant squared of theta. You should memorize all three of these identities, but if you have the first one memorized, then you can derive the other two pretty quickly, the way I just explained. All right, so this is another sort of beast here that we can use. If I give you that the tangent of x equals -8, and I want to find the sine and the cosine, well, let's take a look here. I know that the tangent of x is going to equal, on the unit circle, we might have y over x is -8/1. But that could be the same thing as, I don't know, -16/2, or maybe 24/3. There are lots of different pairs of numbers that I can divide to get -8. So it's not just that ratio of opposite and adjacent is -8, but also it has to be it has to satisfy that Pythagorean identity, right? So so let's take a look here. We have to make sure that this thing fits our Pythagorean identity. So we know that the tangent squared of theta plus 1 equals the secant squared of theta. Or we can replace those thetas with x's in this case. So we know that the tangent of x is -8. So we'll square that. Notice the parentheses. And we can pretty quickly figure out that the secant squared of x is equal to 64 plus 1 is 65. which means that the cosine squared of x equals 1 over 65. Now, when we take the square root of both sides, we have to remember that this is an equation, and when you take the square root of an equation, you get actually two different answers. You get either the positive or negative version of the answer, and it's possible to get two answers. But these problems generally don't get two answers because we're given more information. We know that the sine of x is greater than 0. Okay, so that's going to help us determine whether this is a plus or a minus. So let's think about these two pieces of given information. If the sine of x is greater than 0, then it narrows it down to the angle being either in quadrant 1, where all of them are positive, or quadrant 2, where the sine is positive. However, if the tangent of x is negative, then that means that our angle is either in quadrant 2 or in quadrant 4, places where the two coordinates are opposite signs. So given those two pieces of information, the only overlap here is quadrant 2. So that means that not only do we know that the sine of x is positive, we also know that the cosine of x is negative. So that means that we do not want to consider the positive version of this answer. We know that the cosine of x equals negative root 65 over 65. Don't know why my pen is doing all sorts of wonky things here, right? And I rationalized it, but the point here is that I'm using a negative here. All right, so that doesn't give us the sine, but we can also find the sine of x. Let's see, we can go ahead and maybe we'll go to the Pythagorean identity again and remember that the sine squared of x plus the cosine squared of x has to equal 1. All right, so the sine squared of x plus, let's see, when you square the cosine of x, you get 1 over 65. And that's going to equal, I'll write it as 65 over 65. I'm anticipating the need for common denominators. So when I subtract 1 over 65 from both sides, I get sine squared of x equals 64 over 65. And then when we take the square root of both sides, which one do we want? Do we want the positive version or the negative version? Let's see. Well, the sine of x was given to be positive, so we better pick the positive version. And that's going to be square root of 64 is 8. And we're going to pick the positive version, so we'll do 8 root 65 over 65. Some of you might have been thinking, well, instead of using the Pythagorean theorem to find the sine of x, maybe we could have used the quotient identity, because the sine of x divided by the cosine of x equals the tangent of x. And that would have been another way to go about doing this. They're both completely right. It's really up to you how you do it. As long as you're showing your work, then you should be good.